Good afternoon, everyone. I'm the last obstacle between you and the party tonight, so thank you for being here. My name is Sébastien Stormac. I'm solution architect in the Alexa team, and as it's probably not obvious from my accent, I'm based in London, in UK. And I usually do speak French, as you might have already noticed, with a slight touch of French accent I have. I'm coming from Belgium, the country of waffle, beers, and chocolate. So in this session, I'm going to show you how to build a serverless backend for your Alexa application. So we are going to talk about serverless infrastructure. We are going to talk about lambda, we are going to talk about Cognito, IAM, login with Amazon. These are all the AWS services we are going to use to show you how to create a skill. This is a 300-level session, so I won't go through all the details of how do you create a new skill from scratch, hello world. But in case you miss the Alexa skill kit, you just have to know that with Alexa device, with Echo device, you can add capabilities to your Echo device. So you can add a skill. Think about a skill like being an application. So you can create your own skill. And actually creating a skill, it's super easy to do. You go to the developer console from Amazon. So that's the developer console, developer.amazon.com. You see the list of skills I have. You can create a new one. And creating a skill, it's as easy as creating two different types of artifacts. The first one is the voice interaction, the voice model. What are you going to support in terms of dialogue, in terms of utterances for your skill? So you need to give your skill a name and to define the list of intent. Think about intents like a function. If you're a developer, you know what is a function. A function is something that you can call. So Alexa will call this function in your code to execute these intents. And you need to provide a list of sample utterance for these intents. Hello, hi, hello. All these utterance will be mapped to the hello intent, and at the end, my code will be called to execute that hello intent. When you develop a skill, that's the first part you need to do. The second part is to actually have some kind of web service available somewhere that Alexa can call. And any web service will work. You just need to be available somewhere over the public internet. We will pass you a JSON request, and all you need to do is to give us back another JSON document. So we'll pass you a JSON with the intent and the parameters that we understood from the user speech, and you need to give us back a JSON document. So any type of application can do that. You can use a programming language of your choice, Python, Node.js, Java, C#, and you can host that code anywhere. In the developer console, you can test your skill as well. If I say hello and click there, this is the JSON request that is sent to my code. Alexa recognizes that this is an intent, and it's the hello intent. My account is set up for British English. I have also the timestamp. So this is what I receive in my code, and I need to respond with this, with a speech, a text-to-speech, hello, Sebastian, in which city are you? That's what my demo skill is answering. You can even listen to that from the console.
Hello, Sebastian. In which city are you?
So I can answer as well. I say, hey, I'm in Las Vegas right now, and this is another request sent to your skill. You need to answer something in my code, in this demo.
I heard Las Vegas, and I will remember it for the next time.
And the proof that she will remember it, if I say hello again, the answer will be different now, saying, hey, you are in Vegas.
Hello, Sebastian. Your last known city is Las Vegas.
So that's the basic skill I will go through during the rest of this session and show you how you can deploy and manage a skill like that using serverless infrastructure only. And the same skill works also on the Echo device over there. Alexa, with the microphone it's difficult to pick. Alexa, ask reInvent to say hello.
Hi there.
Okay, she said hi there. So you can test on real device directly from the console as soon as it is enabled in the developer console. So how do you implement a skill like that, and how do you host the backend infrastructure to support a skill like that? We are at reInvent, we are at AWS, so of course we love cloud, and deploying your skill in the cloud has a lot of advantage compared to deploying your skill on premises inside your own server. You can improve the way you're deploying your skill by having a better infrastructure management. You can have identity management linked to your AWS account. I'm going to go into all the details of that in a minute. You can enable persistence for very low cost and low maintenance with tools like DynamoDB, and you can implement extremely fine-grained permission when deploying to AWS. So the architecture, the backend architecture for the skill that I just demoed before, it's like this. You have the Echo device on the left side. Whenever you talk to the Echo device, the Echo talks to the Alexa system, the Alexa service in the cloud, where we do the speech recognition and the natural language processing. I'm using an identity provider where I can authenticate. I will talk about that a bit more later. For this demo, I choose to use login with Amazon, but you can use any identity provider of your choice, login with Google, login with Facebook, your own identity provider. This identity provider, its role is to provide an OAuth token, an authorization token. And that OAuth token, I will use it for many different things. I will use it first to get my profile from the Amazon service. Maybe you noticed that the skill was calling me by my first name. Where is the first name coming from? It's coming from the Amazon profile. But I'm using also the OAuth token to get access to AWS access key and secret key. So to get access to AWS credentials that will give me some authorization to interact with other AWS services. And the other AWS service I'm interacting with, it's DynamoDB. It's my database where I persist the city, my preferred city, for example. How do I get this access key and secret key? I'm using another AWS service called Cognito, and I will go into all the details how this works together, with Lambda being the centerpiece of that. Lambda, it's an execution environment, a code execution environment for your code. So what about the infrastructure? When you design or deploy a skill, you have the Echo, you have the Alexa service, and then you have your code, and you need to host that code somewhere. As I said, it might be any programming language, any type of endpoints. We are perfectly happy if you're hosting your skill code on HTTPS, on a PC below your desk. It might be in any cloud provider, but of course we have a preference for AWS. So if you want to start, and maybe the naive way to deploy your code is to fire a couple of EC2 instances using the AWS CLI or the command line console and deploy your code on these EC2 instance. But then you realize that, hey, your skill must be available 24/7 because your customer are talking to Alexa 24/7 from every different countries. And you might have hundreds of customers talking to your skill at the same time, so you might receive a lot of requests in parallel. So you need to scale, and you need to be highly available. And being highly available and to scale, it's doable, but it's not easy. It's a lot of work to maintain this type of solution. So very quickly, you will come with something like that, with a front layer, a backend layer, load balancer in between the two, load balancer on the top, database with replication. That's a lot of infrastructure to manage for your skill. You need to create this server. Even if AWS has tools to generate that, that's still a lot of work, a lot of virtual machines to install. AWS has a tool that helps you to do that. It's Elastic Beanstalk, but still, it's just a tool that generates all that for you. You still have to maintain that. So the alternative I'm using today is to go serverless. No Linux, no virtual machines, no Windows. I'm using Lambda, DynamoDB, and Cognito. So Lambda, as you probably know already, Lambda, it's a service that has been introduced 2 years ago here in reInvent. And it's a service where me, as a developer, I can upload my code, and AWS takes care of all the rest. So AWS will execute that code for me. It will make the service highly available for me. So if for whatever reason one Lambda instance, container, or whatever you call it, fails, it will be replaced automatically. And Lambda will also scale. I can have 1 call per second or 1,000 calls per minute. We will make Lambda scale to adapt to your workload. Lambda code is extremely easy to use as well. Yeah, you can see my screen. So if you go to the Lambda console, you can create a Lambda function We do provide a couple of templates, including for Alexa. So we have 6 Alexa templates. I will use this one. That's a very simple how-to skill implemented as a Lambda function. You need to tell us what other service will be authorized to call your Lambda function. So what are the triggers for this Lambda function? For Alexa, it's an Alexa skill. So let's go next. Then I give my function a name, a runtime. Lambda does support today JavaScript, Python, Java, and this morning, if you were in the keynote from Werner, you heard that we also added C# and .NET to Lambda. For quite simple code, you can edit your code directly here. In real life, you will probably use an IDE, zip your files, and upload your files to the Lambda function. You need to give us a role. A role is very important, and I'm going to talk a lot about roles in the rest of this session. The role is the set of permission you want to give to your Lambda function. So whenever we will execute your Lambda function, it will have the permission defined in the role. If your Lambda function needs to talk to DynamoDB, you need to create a role that gives your Lambda function permission to read or to write to selected tables in DynamoDB. So let's take the Lambda basic execution role and create the function. Oops. So it takes 2 or 3 seconds, and then the function is created. You can even test the function directly from the console. You can configure a test event, and we do propose test event for Alexa. So that's exactly the JSON that Alexa will send to your Lambda function. You don't need to type that or to capture that in the Alexa developer console. Let's save and test. And I'm invoking my Lambda function, and I can immediately see the result here. Welcome to American Minecraft Helper. That's the code that has been deployed. So in 1.5 minutes in front of you, while talking, I create a Lambda function, authorize that Lambda function to be called from Alexa, give a couple of permissions to that Lambda function, and test that code. So Lambda, extremely easy to use, extremely cost-effective as well, because for Lambda, you are charged per invocation, so the number of time your Lambda function will trigger and execute, and the cost is $20 cents, 0.2 per million of invocation. And the good news is that the first million of invocation every month is for free. So you can get a lot of traffic for the price of a coffee on Lambda. If you deploy to Lambda, you have no more Linux server to manage, no more patching, no more upgrade of runtime, Java, Python, whatever, no libraries, dependencies, zero-day vulnerability to patch. So you really lower the operational efforts that you need to maintain your software. You lower the cost as well. I told you 20 cents per million of invocation, and you automatically benefit from an internet-type scalability. You can have thousands of calls per hour, and Lambda is designed for very high availability. So that's my first step in my improvement, going from on-premise to the cloud. Get rid of your server, deploy your code on Lambda, especially for Alexa skills. The second thing I would like to improve, taking advantage of while running on AWS, is to improve the identity management side of things. Every time me, as a user, I'm talking to Alexa, Alexa generates a JSON file and sends that JSON file to your skill. And inside your JSON file, you receive something like that. User ID equal Amazon, blah, 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 blah. That's a unique identifier for the person which is actually talking to the echo. So it allows you to detect when a customer is talking for the very first time to your skill, or if it is a returning customer, for example. With that ID, of course, you don't know it's me, you don't know it's Sebastian talking to your skill, but at least you know it's user 123, and it's the same user coming back from one day to the other. This user ID is generated at the time where you enable the skill. So you, as an Alexa user, you go to the Alexa app, you choose a skill, you click enable. This is when we generate this user ID. So this user ID, it's stable as long as you're using the same Amazon account. If you have multiple devices connected in your home on multiple Amazon accounts, the user ID will be different. And it's stable as long as the skill stays enabled. If you disable the skill, re-enable the skill, it will be a different user ID. And maybe you want to keep track in a better way of who is talking to your code. Think about skills like Domino Pizza or Uber. When I enable the skill on Uber, they know it's me because they have my credit card and they want to charge me for the service I'm going to use. So how can you do that with Alexa? How can you recognize users across multiple Amazon accounts? Or how can you have a stable identity, even if your customer disable and re-enable the skill? The way we do that with Alexa, it's called account linking. So at the time where you enable the skill, me as a user, I'm redirected to a third-party website where I will authenticate with my credentials, like my username and password on the Uber website. And that Uber website will generate a token, will give it back to Alexa, and every time Alexa will call your skill, will give you the token. So inside your code, you will receive an OAuth token, and you can use that token to make API call or to get access key, secret key on AWS. I will show you that in a minute. So for that to work, the only things you need to do or to have, it's an identity provider, a user interface where your customer can enter a username and password, which is compliant with the OAuth 2.0 specification. For this example, I'm using Login with Amazon. Login with Amazon is an excellent public identity provider because I guess all of you here have an Amazon account, and it's an Amazon account extremely precise because we know your first name, last name, email address, delivery address, and your credit card. But of course, any OAuth 2.0 provider will work. You can use Login with Google, Login with Facebook, your own OAuth provider. Anything which is OAuth 2.0 compliant should work. How do you create that in the Alexa developer console? How do you configure that in the Alexa developer console? You need to give us a couple of information. You need to give us, here on the top part of the screen, the authorization URL. So this is where we are going to bring your customer. This is the login page that we want to display. You need to give a couple of other details. I want to go into all the details. At the end, there is another very important URL. It's the access token URI. This is given by your identity provider as well. We need to know that. We need to know your client secret. Most of the time, it involves setting up an application on the identity provider website. So if you're using Google, Facebook, or Amazon, you need to go to one of these three websites and say, hey, I have an Alexa skill. That's the name of my application. And I want to use that to authenticate. The full flow is there. Because it's the end of the day, it's the afternoon. I will be nice with you, so I will not go through into all the details of that one. But it's much more simpler than it looks like. The idea is me, as a user, I enable a skill, I'm redirected to the login page, I enter my username and password, I receive usually a second screen that says, hey, do you authorize this application to access your profile? I click yes. At that time, the website, the authentication website, the IDP, identity provider, generates a code and sends that code back to Alexa. So Alexa in the cloud receives just a code, not the OAuth token, just a code. And with that code, we'll make a second API call to your IDP saying, hey guy, I just received a code. Can I receive an OAuth token for that code? And that exchange happens on the back end. It's not going through the user agent. It's not going through the web interface. So the OAuth token is never exposed to your customer. It's something that happens only in the back end. So in the back end, Alexa receives the OAuth token and will store that OAuth token and will give that token every time the customer talks to your skill. If the OAuth token expires, we will call the IDP again saying, hey guys, your OAuth token expired, can I get a new one? Of course, you need to have some kind of authentication to do that. We call that a refresh token, and we store both in the Alexa service in the cloud. If you want to have a detailed step-by-step instruction how to set up a skill with account linking and login with Amazon, there is a blog article that I wrote a couple of months ago. You can take a picture of the URL. I create a short URL for you that gives you really step-by-step instruction how to create a skill with account linking and login with Amazon, but it's quite easy to adapt to another type of identity provider. So linking the customer account to the Alexa account brings some benefits to your skill. First, you have a user ID, which is stable over time. So even if I disable the skill and re-enable the skill, you still receive the same user ID, so you still know it's me. You can call a profile service to get more details about me, my first name, my last name. You can use this information to store that inside your database. You can also have the same IDP across multiple skills, so multiple skills synchronizing about my identity and knowing it's me and exchanging information. So that's a better way to manage user identities on Alexa. The next step in terms of managing identities is to get rid of the lambda generic policies. Remember when I create my lambda function, I told you you need to associate a role to your lambda function, and that role is the list of permission the lambda function will have when it executes. But that role is the same for all users. Whoever is talking to your skill, authenticated or non-authenticated, it's the same permission because the permissions are associated with the lambda function itself. What if you can get an access key, secret key, you can get AWS credentials that are specific to me as a customer. I'm Sebastian, and I will receive an access key, secret key, which limits what can I do on AWS on the back end. So the idea would be to trade, to exchange the OAuth token I received from login with Amazon for a pair of access key and secret key. And this is exactly what Cognito allows you to do. So Cognito is also a new service that we introduced 2-3 years ago. It allows to do tons of different things, but the things I'm going to use it, I'm using it right now, is just to do that. Given the OAuth token I received from login with Amazon, I'm calling Cognito to say, hey Cognito, give me an access key, secret key. And that access key, secret key is a bit different than a usual access key, secret key you receive from IAM. It's limited in time, so it's only valid for a short period of time, and it's limited in scope, so you can associate a role to that access key, secret key. And if you assume that role, it means that the code, the skill code, will be limited to whatever policies you have defined on the Cognito side. It looks complicated like that, but it's not. The code to do that fits on one single screen, and actually that's one of my quality metrics when I'm writing code. It has to fit on one single screen for a presentation like this one. So let's zoom a bit into that. The first part is to configure the AWS global objects. This is Node.js and JavaScript, but you can adapt that to any other programming language. So my demo runs from the European region of AWS. Then you need to create a Cognito identity credential object. When you configure Cognito on the server side, you will receive a Cognito pool ID. That's the ID on the second line of code over there. So that's the ID of my Cognito pool, my list of users, if you want. And then I can give to Cognito a couple of logins. In this case, I have only one from login with Amazon. And LWA user token is actually the variable that contains the OAuth token I received from login with Amazon. So when I have this credential provider ready, the next step is just to call get or refresh. Refresh to refresh the token, the access key, secret key, get to get the first one. It's an asynchronous call, but when the call eventually returns, I will receive an AWS access key and secret key. Not a generic one for my Lambda function, but something specific for the user that has been connected. Actually, you have two different types of access key, secret key, one for non-authenticated user and one for authenticated user. So at this stage, my Lambda function will run with credentials that are specific for all my authenticated users. And I can separate the user that have not been through account linking with the user that have been through account linking and grant different permission on different AWS services. Benefits of that, you have a stable identity because one of the services that Cognito can do is to give you a common user ID. So whatever is your OAuth token, login with Facebook, login with Google, login with Amazon, you receive a Cognito user ID and it will be always the same. So if someone starts his interaction with an application that you develop on a Fire tablet, for example, and use login with Google on the tablet and then a bit later login with Amazon, on the Echo, you receive the same user ID. So it's a stable identity across multiple providers. And the credentials that you receive are limited in time and limited in scope. I know it's a bit hard for the end of the afternoon. Let's move on next one. So we first talk about going serverless with Lambda. Then I talk about how to better manage identities in the cloud using Cognito and login with Amazon. What about persistence? We think and we observe that the skills that have a lot of success are the skills that behave like a human person. The more you can get conversational with Echo, the more magical is the experience for the end user. So designing your voice user interface is super important, and remembering what your user said or your preference or whatever, remembering the context, the state is also very important to create the illusion that you're actually talking to a person. Human persons are much better than computer to remember the context or to remember things. My wife remembers things I told her 10 years ago. I'm pretty sure yours does too. So persistence, it's important to remember user preference or to remember the history of the conversation. So you need a database. But we are in a serverless world, so I don't want to create a virtual machine, Linux, Windows, install MySQL, patch that, maintain that. No, I want to manage service that does that for me. And in this context, I would like to use DynamoDB. DynamoDB, it's a managed service from AWS. It's a NoSQL database managed in the cloud. From a developer perspective, all I need to do to use DynamoDB is to go to the console, create a table, give a couple of additional details about that table, like what will be the primary key, what will be the hash key, what will be the throughput. Do you expect to do 5 write per second or 1 million write per second? Of course, it's not the same size of the infrastructure on our side. But once you've done that, we will create the infrastructure for you, and you have a service that you can call to write, read, search items in DynamoDB. How to use DynamoDB from a skill? It's integrated by default in our SDK for Node.js. So if you are writing your own skill in Node.js, in JavaScript, the SDK that we provide on GitHub knows about DynamoDB per default. So whatever you store in the Alexa session will be persisted or might be persisted automatically to DynamoDB. You do not need to write a single line of code. Oh, that's not true. You need to write one line of code that gives us the name of the table. But as soon as we have the name of the table, we will create the table for you automatically at the first time if it does not exist yet. And we will automatically retrieve the argument for a new session and store your data back to DynamoDB at the end of the session. And all that happens automatically in the SDK. So that's how do you do that. This is the session. You have attributes, it's a list of key value, and when you want to save the session, you emit an event called save. And the SDK will take the session content and will store that into DynamoDB for you automatically. If you want to get a bit more fine-grained control of what you read or search or store on DynamoDB, of course you can write DynamoDB client code inside your skill as well. And once again, it's code that fits on the screen. It's not really complicated. The first part on the top of the screen is the configuration of the AWS SDK itself. You select the region, you create a DynamoDB client, you prepare your parameter. These are the parameters to retrieve, to read one single record from DynamoDB. So I need to give the table name and the key. I'm using the Cognito user ID here as the key. And then you make your call on the client.get. Once again, it's asynchronous, so you need to have a callback or promises. And when the callback is called, you receive the data or no data if there is no matching records inside DynamoDB. So a few lines of code, 10, 15 lines of code, and you can read and write from DynamoDB. So DynamoDB is entirely managed. There is no patching, no upgrade required on your side. It's scale at, yeah, we used to say internet scale. We have a customer that a couple of years ago, it's an old example from 2-3 years ago, a customer that scale for commercial TV commercial advertising, he scaled the database to accept more traffic when the commercial was broadcasted on air, and they scaled to 500,000 writes per second, 500,000 write operation per second. And of course, after that, they descale, they reduce the footprint of DynamoDB because you are charged based on that capacity. Very cost effective as well. You can start with DynamoDB for free or almost. So what about permission? If you are associating the permission role to your Lambda function, you have the basic execution that just allows you to read and write from CloudWatch log. What if we do something much more fine-grained for DynamoDB? So what if you want to limit access to DynamoDB? Using AWS policies, you can define what your skill can do. So this is an IAM policy that gives authorization to use AWS services. The first line is the effect of the policy. You allow or you deny something. The second line, you tell what do you authorize or what do you deny. In this case, I want to authorize my function to call on get item, put item, update item, so to read, to write, and to update an item in DynamoDB. Then you can restrict on a couple of resources, like where, which table. In this example, I'm only storing that in Alexa user. That's the name of the table I'm using there. But the most important part in this policy is the condition part. What if I can restrict my code to only read and write profile for the connected user and not for someone else? I'm authenticated with login with Amazon, so I have an OAuth token. So the skill has exchanged that OAuth token for an access key secret key that allows me to read and write from DynamoDB. And Cognito gives me a user ID. So Cognito knows that I'm Cognito user 123. What if you want to create a really fine-grained policy that will tell to your skill you can only read and write items in DynamoDB if it is my item and not someone else? So in technical words, the condition there says you can only read and write from DynamoDB if the primary key, if the hash key is actually my Cognito user ID. So if you have a bug in your code or something bad happened, with that permission, someone which is authenticated for your skill that has gone through account linking can only access his profile, and it cannot read other lines, other records from DynamoDB. So instead of granting access to a table, you grant access to specific records on the table. Using this variable, you can say, I can only read and write items where the Cognito user ID is the primary key, is the hash key. Is it clear? Yep. So benefits of roles. You have different access policies for Lambda between your authenticated user and non-authenticated user. And you can further refine the permission on DynamoDB to grant your skill access to only the records that match your user ID. That's a lot of change in 40 minutes. So I've been through 4 different types of improvement compared to a traditional on-premises infrastructure. The first improvement was to get rid of your infrastructure, get rid of your server, do not start, maintain, operate Linux, Windows server in the cloud, go serverless. And to do that, I propose to move the code to Lambda. The second thing is to improve identity management. Alexa by default generates a user ID, but that user ID is only stable as long as you have the skill enabled. If you disable and re-enable, you have another user ID. So by using account linking and using an identity provider, such as login with Amazon, login with Facebook, or login with Google or anything else, you can oblige your user to authenticate themselves before they start to use the skill. And when doing so, you receive an OAuth token, and every time we will invoke your skill code, you get that OAuth token. With that OAuth token, you can make API call on your backend, or you can do some fancy stuff with AWS and Cognito to exchange the OAuth token for an AWS access key, secret key. And by doing so, you give AWS permission that are specific for your authenticated user. Different set of permission for anonymous user and for authenticated user. Then you can enable persistence to make Alexa behave like a person, to remember the context of that conversation, remember what you said last, remember what you bought, remember. There are tons of examples for persistence and Alexa. I'm working with a radio provider in the UK. It's called Radio Player. So they have a skill. You can say, hey, Alexa, ask Radio Player to play BBC Radio 1. And the very first time I'm invoking the skill will ask me where I am, what is my closest big city, and it will remember that to propose me a selection of local radio station. And of course, at any time, I can change that. That's an example of using persistence. If you have identity management and persistence, you don't want to grant access to your entire database, to your skill. You want to refine the access to specific lines, to specific item. And this is what you can do with IAM policies. By using conditions inside your policy, you can tell IAM, please restrict access not only to the table, but to specific records into that table, the record that match the user identity. And inside your code, your skill code, you can read and write only these. Let me show you how it works on DynamoDB. So remember, when I'm calling my skill, it remembers my first name, it remembers my city. It's because in DynamoDB, you see my screen? You can see my screen. I have a table called Alexa users. The primary key here is my Cognito user ID. And then all my preferences are stored there. So if I delete this, delete, and test the skill again, saying hello, the prompt I will receive is a bit different.
Hello, Sebastian. In which city are you?
So how does it know my first name? It knows because it goes first to DynamoDB, but it's not there. I just delete the record. So it's calling the profile service from Login with Amazon. And in the profile service, it can retrieve my first name and last name. And it stores that in the database for the next call, because it's much faster to go read from DynamoDB than to call the profiling service from Amazon. So at this stage, I should have just the Cognito user ID and the first name. So it asks me, in which city are you? At this stage, the session is lost. There is no context for Alexa. The next invocation will be a separate lambda call. So I can give, let's do something more exotic than Las Vegas, Brussels.
I heard Brussels, and I will remember it for the next time.
And the proof that she remembers it is that if I refresh my table there, I have the city ID and the city name that came there. And the skill, when it runs within Alexa, has only the authorization to read and write items that start with the Cognito ID of the currently authenticated user. The skill has no authorization to run or to read or write items on different Cognito ID. That's basically it for me. So thank you for staying until the end. I hope you enjoyed the conference so far, that you enjoyed the party. You can follow me on Sepsto on Twitter. It's very important as well to fill in your evaluation, so please take a few minutes to complete your evaluation. We had many different Alexa sessions this week. Obviously, we are on Thursday, so the two that are left for tomorrow are at the Venetian in the morning, 9:30 and 11 a.m. Any question? Happy to take that offline. Thank you.